a question that deals with temperature and pressure. Question 8.79 reads, a sample of hydrogen gas at 127 degrees Celsius has a pressure of 2 atmospheres. At what final temperature in degrees Celsius will the pressure of the hydrogen decrease to 0.25 atmospheres if volume and the number of moles are constant? So let's write down what we know, and we know that our initial temperature, so T1, is 127 degrees Celsius. Probably you know, if you've done any kind of practice in gas laws, you know that temperature in degrees Celsius has to be converted into Kelvin, so we add 273 to that, and we get the temperature in Kelvin, which just happens to be 400 Kelvin. We put a decimal because we want it to read as 3 sig figs. The initial pressure, P1, is 2.00 atmospheres. It's saying at what final temperature, so that's the question. So T2, we're going to put, that's our question mark, that'll be our variable, and it says, will the pressure decrease to 0.25 atmospheres? So our final pressure, our P2, is going to be 0.25 atmospheres. And of course, again, it's telling us that volume and the number of moles are constant, so we don't have to worry about those in this problem. So hopefully you recognize that when we're dealing with temperature and pressure only, that we can apply Gay-Lussac's law. So Gay-Lussac's law. So it's a good idea to know this law and commit it to memory, which is P1 over T1 is equal to P2 over T2. And in this case, we're solving for T2. So I'm just going to write it down here. Hopefully you can solve this algebraically in your head, and you see that T2 is going to be equal to the second pressure times the initial temperature divided by the initial pressure. So if I plug in my numbers, so for my second pressure, I'm going to put in my 0.25 atmospheres, and then my initial temperature, which again was 400 Kelvin. So again, I have to put it in Kelvin. And my initial pressure was 2.00 atmospheres, like that. So you can see the units canceling out. So you can see the atmospheres and atmospheres are canceling out, and I'm left over with Kelvin. I only have 2 sig figs in the second pressure, so that means my final answer will have 2 sig figs. So 50 Kelvin is what I'll get. And of course, to convert that into Celsius, I subtract 273 from that, and I would get negative 223 degrees Celsius. So this is how you use Gay-Lussac's law. And again, it's a good idea to commit Gay-Lussac's law to memory.